Hey everyone! Today we're diving into a really powerful tool in algebra called completing the square. It's this awesome way to take any quadratic equation and totally transform it so you can see its secrets almost instantly. Ready to jump in? Let's do it.
So I want you to think about this like a puzzle. On one side, you've got this form, the standard quadratic equation. You've seen this a million times, right? Our mission is to morph it into this other form on the right, the completed square form. Now, they might look totally different, but trust me, they're just two sides of the same coin. They're the exact same equation, just wearing a different outfit.
But why? Why go through all this trouble? Well, here's the magic. That completed square form, the ax plus p squared plus q, it's like a secret decoder ring for the quadratic. It straight up tells you the vertex. You know, the turning point of that parabola, at the coordinates, negative p, q. No extra work needed. This makes graphing it and figuring out what it's doing so much easier.
So, how do we solve this puzzle? It's actually way simpler than it looks. You only need two key formulas. That's it. These two little equations are the only tools you'll need in your toolkit to handle any quadratic you come across. So, what are they?
And here they are. First, to find p, you just grab your b value and divide it by 2 times your a value. Super simple. Then, once you've got p, you just plug it into the second formula to find q. That's the whole game plan. A nice, clean, two-step process. Okay, enough talk. Let's actually see how this works.
All right, let's ease into this. We're going to start with a really straightforward example, just so we can get a feel for how it all flows. For now, just sit back and watch. The goal here is just to see the process in action.
Okay, here's our first patient, x squared minus 6x plus 8. Our job is to take this and rewrite it in that shiny completed square form.
First things first, and this is always your first step, no matter what, you've got to identify your a, b, and c. So, looking at our equation, a, the number in front of the x squared, is just 1. B is negative 6, and our constant c at the end is 8. Easy enough, right?
Okay, time to pull out that first formula. To get p, we take b and divide it by 2 times a. We know b is negative 6 and a is 1, so we're literally just plugging those numbers right into the formula. Nothing more to it.
And the math here is pretty friendly. Negative 6 divided by 2, that gives us negative 3. And just like that, we've found our p. Boom, we are halfway there.
All right, on to the second piece of the puzzle, q. We're going to use our second formula. We take our c, which is 8, and we subtract a times our new p-value squared. So that's 8 minus 1 times, careful now, negative 3 squared. The order you do this in really matters, so pay close attention.
Yeah, got to be really careful here. First, we square the negative 3, which gives us a positive 9. So what we really have is 8 minus 9, and that leaves us with a q value of negative 1. And that's it. We've got both p and q. We have all the pieces we need.
Now for the fun part, putting it all together. Remember the template? It's a times x plus p squared plus q. Since our a was just 1, we can kind of ignore it out front. We found p is negative 3 and q is negative 1, so we just pop them in. Our final form is x minus 3 squared minus 1, and puzzle solved.
So here's a quick look at the whole journey we just took. We started by identifying a, b, and c. Then we calculated p, used that to calculate q, and finally assembled the whole thing. See? When you lay it all out, it's a really clean and logical process.
Okay, that was a pretty nice warm-up, wasn't it? But life isn't always that neat. What happens when the numbers get a little messy? Let's level up the difficulty and throw some new challenges at this method to see how it holds up. All right, check this one out. X squared minus 3x minus 3. See that b value? It's a negative 3, an odd number. That's usually a little hint that we're about to run into some fractions. But don't let that scare you. The process, the core method, stays exactly the same.
And, yup, just as we suspected. After we run this through our trusty formulas, we end up with fractions. We get p equals negative 3 over 2, and q is negative 21 over 4. And you know what? That's totally fine. This is a great example of how you can just trust the formulas. They work every single time, even when the numbers look a bit ugly.
Okay, so we've tackled negative numbers, we've wrestled with fractions. What else is there? Well, there's one more big hurdle you'll see pretty often. What in the world do we do if that a value, the number out front of the x squared, isn't just a nice, simple 1?
Let's bring in our final challenger, 2x squared minus 12x plus 13. Honestly, this is about as tricky as these problems usually get. If you can handle this, you can handle anything. So where do we begin? You guessed it, the exact same place we always do. Identify the variables. The only thing that's new here is that our a is now 2, our b is -12, and our c is 13. See, the first step never changes.
And would you look at that? We take our new values, including that a is 2, and we plug them into the exact same formulas we've been using all along, and they still work perfectly. We end up with p equals -3 and q equals -5. Our final answer becomes 2 times x minus 3 squared minus 5. It just goes to show how powerful and reliable this method really is.
And there you have it. We've walked through it all. We started with the simple stuff, we navigated through some messy fractions, and we even conquered problems where a wasn't 1. You've basically just added a new superpower to your math toolkit.
So let's just boil it down one last time. What's the recipe? Step 1. Always identify A, B, and C. Step 2. Use the first formula to calculate P. Step 3. Use your new P-value in the second formula to find Q. And Step 4. Just plug all those values back into that final form. That's it. A simple 4-step process that will work on any quadratic you throw at it.
So the real question is, now that you have this skill, what are you going to do with it? Completing the square isn't just a neat party trick. It's the key that unlocks how to solve quadratic equations, it's how the famous quadratic formula is derived, it even helps with things like the equations of circles. So I'll leave you with this. What new doors in algebra are you ready to open?